So we are going to go through quickly how to identify trees. And we're going to start with looking at the first way, any way you identify anything, when you're looking at flowers, when you're looking at reptiles, amphibians, and insects, you're going to look at the different characteristics of whatever that organism is. And obviously trees are no different. And when we walk up to a tree, usually from a distance, and as you walk up closer, one of the first things you see are the leaves, because you can see that from a distance. But we get close and we're going to see twigs and buds, flowers, especially in the spring. And we're starting to see some that have already starting to flower, fruit as we go into the growing season, and then bark. And a lot of times bark, people love bark because there are some trees we have out there that are have very unique bark. But bark can be tricky because it does tend to change with a tree's life, not on all species, but on many species. It may look one way when that tree is small and young, and as it grows, that bark's going to maybe even change colors, break up into furrows, so it'll look a little bit different. But this is a great example. I'm sure everybody knows that is an American sycamore. It's a great tree to identify by bark. If you're out in the landscape and you see those white branches up in the canopy, you know that's an American sycamore. You don't need to see the leaves, the fruit, or anything else. So it's a good one to do by bark, but a lot of the rest of them aren't. So today we're going to focus on leaves, and they're going to start coming out soon. So we'll be able to start tackling some identification here soon. But a real quick, just note, a warning, when you're looking at leaves, you want to make sure when you're standing in front of that tree that you look at more than one leaf. Don't just pick up one and go, oh yeah, that's what this is. Because leaves don't always look the same, even of the same species and on the same trees. You can see we've got 3 black oak leaves here, very broad, even kind of thin looking. I mean, it almost looks like it. Yeah, it doesn't even look like these other 2. This one's got much deeper sinuses and more pointy lobes. And then this one actually almost looks evergreen. So you want to make sure you look at several different examples on your tree. And this is also very true when we're looking at our conifers, our trees with needle-like leaves. So the first thing when you're looking at a tree, you walk up to it, you're looking at those leaves, you're going to determine, are they needle-like leaves or are they broadleaves? And our needle-like leaves, as Billy said, we only have a few species, I think 8 species that are native here to Kentucky, bald cypress being one of them. It has a needle-like leaf. And then everything else has broad leaves. So this would be our things like this shellbark hickory or our bur oak, that nice big flat broad leaf. So let's talk real quick about our conifers, or our needle bearing trees or cone bearing trees. So on conifers, we have needles in a couple of different arrangements, and that helps with the identification. We've got scale-like, those overlapping little scales. Think of like on a snake almost, but they're a little more pronounced than that. Or we've got single type needles. They're individually attached to the twig. And then we have needles that are grouped together in little bundles, and it's like in a little woody cup. It's called a fascicle, but the needles will be grouped together in 2s up to 5s. And we'll look at a few examples here. And these are our species of cone-bearing or needle-bearing trees here, our conifers here in the state. We have eastern red cedar, which is our top one here. And it has, as you can see, not the ones on the very end of the branch, but on the bottom, they are compressed scale-like needles. And then this is the new growth on the tip of the branch, and it'll tend to be more spiky as it's first starting to grow, eventually turning into more of a compressed needle. And then we've got our northern white cedar, which we don't have all over the state. It does get planted a lot. It's one of those we plant a lot in cemeteries. And it has very soft foliage. Actually, if you cut a branch and lay it down, it's going to lay flat the way the sprays are on that, whereas our eastern red cedar won't do that. And the northern white cedar is not going to have the sharp, prickly new growth on it like the eastern red cedar. So let's look at our single needles, and we have eastern hemlock. People, I'm sure you know and love this tree, and we worry for it greatly with the hemlock woolly adelgid, but it's a really important tree of our cove forest ecosystems. And its needles are individual, and they there's my little mouse goes. You see there's one needle attached to that twig and then another needle attached to that twig. So it's singly attached. And then the same for the bald cypress. You get single needles attached to the twig. Now, note on bald cypress, while everything else we're looking at here is an evergreen, when we think of conifers, we think of evergreen, as Billy mentioned. Bald cypress is an exception to that. It is our deciduous conifer in the state. So it doesn't have needles right now. It's just getting ready to grow those needles for the spring. And now we're talking about needles in bundles. And the big one we think about is eastern white pine. And it has needles in groups of 5. So if you think of white, W-H-I-T-E, that's 5 letters, white pine. So you can go down to the stem on here and look at that little cup, and you could count those up without even pulling it off, count those needles, and you'd count 5. And this is where it's really important that you look at more than one set of fascicles, because sometimes a needle could fall out or somebody brush up against it. So look at more than one. So eastern white pine, 5 needles. This is a common, obviously we know a common tree in our landscapes. We plant it a lot to make screens, but we do find it out in our ecosystems as well. And then there's pitch pine. And this is really more of a true forested tree. We would consider this more of a lumber bearing tree. And our pitch pine, it has needles in groups of 3, and they're always in groups of 3. And they're about 3 inches long. And you can see nice 3 inches long needles and always in groups of 3. And that's important because the tree that it also looks very much alike in the woods, and they will be in the same location within the woods, is the shortleaf pine. And the shortleaf pine has needles in groups of 2s and 3s. So that's why it's important to make sure you look at multiple sets of these fascicles. So shortleaf in 2s and 3s, pitch pine only in 3s. And then lastly, we've got our Virginia pine. People also call it scrub pine. This is the one that'll grow along our road cuts, up in the tops of our ridges. I mean, just the driest, sandiest, least fertile type soils. And its needles are in groups of 2. You can see that. And they tend to be short, maybe 2 inches, maybe shorter, maybe a little bit longer. But a lot of times they're twisted, almost like they're in a little embrace. So those are our, and that's Virginia pine. So those are our conifers. So that's 8 of the 120 plus species we talked about. So let's look at some of the broadleaf characteristics that we're going to want to focus on when we are learning to identify our trees by their leaves. So we'll talk about leaf arrangement. We're going to look at leaf form. We'll go over what all of these means. Leaf margin. And even the leaf tips can be a good characteristic, what the base of the leaf looks like. And I also want to just point out, it's important to look at the bud, especially like this time of year. So this is how you can identify trees in the winter when we don't have leaves. You can use a special tool for identification of buds. But knowing where your buds are, you've got a terminal bud. That's the one for shoot elongation. And that's going to be at the tip of the branch. And then you've got your lateral buds, and this is next year's leaf. And that mark below it is the leaf scar from last year's leaf. And these are important in this time of year because it's going to help you determine leaf arrangement, if they're arranged alternately or oppositely on that branch. And basically the buds are just the location of the new stems, fruits, and leaves. So we'll look at a few buds here. I love this guy. It looks like a moth antenna, dark and feathery on our pawpaw. And here we have a red maple. Those little guys are side by side. This one's great, the duck bill. And this is our terminal bud on our on our yellow poplar. And this great big bud here is from our buckeyes. We got great big leaves, so it's got a great big bud. Sharp, pointy little buds, and this is on our American beech. And then finally on our oaks, which we have many of them in the state, it tends to have its terminal buds they'll have multiple buds at the end of the branch there. All right, so we talked about if we've got needles or broadleaves. Now let's talk about leaf arrangement. So our leaves can be arranged oppositely, as we see here. So those leaves are right across each other on that branch. Think about leaves right across the street. And if you can remember the mnemonic Mad Buck, you can remember the groups of trees that we have in the state that have oppositely arranged leaves. Those are maples, ashes, dogwoods, and buckeyes. Now we have numerous maples, numerous ashes, numerous dogwoods, and numerous buckeyes. But if your tree has oppositely arranged leaves and it's a native tree, you're out in the woods, you're going to have a maple, ash, or dogwood or buckeye. And then most of our remaining species are alternate. And this is when those leaves are kind of zigzagged on that branch. So they're not right across, but they are in a zigzag pattern on that branch. So that gives you that alternate leaf arrangement. We do have one species, the northern catalpa, which has whorled leaves. And so those are whorled all right at the same area around that twig. And we had talked about the northern catalpa in one of the questions, but yeah, northern catalpa, whorled leaves. Okay, so let's just look at a few actual pictures. So here we have this American beech has, as you can see, our leaves and you can see our buds. They're zigzagged on that branch, so they are alternately arranged. And we pop over here to opposite on our maples. Remember, maple, ash, dogwood, buckeye. They're oppositely arranged. You can see the buds are as well as the leaf stems. Okay, the next thing you look at is leaf form. So with leaf form, we're going to look at where our bud is located. So we've got a couple of different kinds of leaf forms. We have simple, and then we've got compound, and our compound can be broken down into palmately, pinnately, and bipinnately. So to figure out if you've got a simple leaf, you're going to look at the blade that you've got right here, and you're going to go down that leaf stem, and you're going to see if there is a bud at the base. And if there is a bud at the base of that leaf stem, and there's only one blade, you got a simple leaf. And a lot of our trees have simple leaves. A lot of our maples are simple leaves. Dogwoods are simple leaves. Redbuds are simple leaves. Oaks are simple leaves. So a lot of trees have simple leaves. But now we walk up to this guy, and we're looking at this, and we look at this leaf here. We think this is the main leaf, but we look at the base and we're not finding a bud. We don't see a bud at the base of any of these. So we continue to move down this larger leaf stem, and we find that the bud is down here. So we have our bud down here, and we actually have a palmately, so it's shaped like your hand, palmately compound leaf. And these, what we thought were leaves, are actually called leaflets. And this, an example of this would be our buckeyes. They have palmately compound leaves. And then the next one, and this is where we find a lot of our compounds, trees have pinnately, and pinnately is like a feather, that pinnately compound. So you look at the base of each one of these, what you think is the leaf, and you're not finding a bud anywhere, and you keep moving down that stem until you find that the bud's all the way down here. So this whole thing is a leaf that's made up of 2, 4, 6, 8, 10, 11 leaflets, and that's pinnately compound. Think black walnut, think hickories. Those are pinnately compound trees. And then this big guy here, this is a big leaf. There are no buds at the base of these leaflets. There's no buds at what we think may be a compound leaf. Instead, our buds all the way down here. And this whole thing is bipinnately or doubly pinnately compound. And an example of this is our Kentucky coffee tree. It has a really big leaf. As you can see, that's a big leaf. So leaf form. So remember, we got leaf type, needle or broadleaf. We got leaf arrangement, alternate or opposite. And then we have leaf form, simple or compound. Okay, so we'll look at a few simple leaves. So there's our buds, we've got a stem, and we've got one blade. So this is a simple leaf. Now here's one that we're looking, and we don't all along the base of these, what we think are leaves, but that don't find a bud. Instead, we find our bud all the way down here. And even in this picture, you can see how large that bud is. So those are our buds. So this whole grouping here is a leaf, and this is on our black walnut. Trees that have compound leaves tend to have large buds because obviously this is a very large leaf. Okay, so now we look at the leaf margin, and that's just the edge of the leaf. So we can have unlobed or entire leaves. So lobes mean like indentations in on it. And this one up here has no indentations. It doesn't have any prickles or any teeth along the edges. Neither does this magnolia down here. So we would have an entire unlobed leaf. Now, when we look at, and I hope everybody knows, these are our examples of our oaks. We have lobed leaves. Now, not all oaks are lobes, but most of our oak trees have lobed leaves. So the lobe is the part that sticks out. You think like your earlobe, and the part that is the indentation, looks like where you stuck your thumb in there. That's called the sinus. And depending on the oak, they'll have deep sinuses or not deep sinuses. They could have lobes that have bristle tips on them, like little hair-like tips, or they can be just completely rounded like this. Generally, our red oaks have bristle-tipped lobes, and our white oaks don't. They have rounded lobes. And then we could have leaves that have serrations. And, you think of serrations as think of a serrated knife or something. Can have very fine serrations, little teeth along the edges of the leaf, or they can have even big, broad serrations, kind of like a bread knife, like we would find on the American beach. But we can also have leaves that are lobed, like this red maple, 1, 2, 3 lobes, and serrated. So they've got teeth along the edges, and they are lobed as well. So there's a lot of different characteristics to look at, but I'm going to introduce you to a tool that walks you through the order of this and explains it as it's going along. But before we do that, let's do a quick review. Conifer or broadleaf, and hopefully everybody says this is a conifer. Opposite or alternate, hopefully everybody gets opposite. Alternate or opposite. Zigzagged on there, isn't it? So it's alternate. Simple or compound. Well, you can't see up close here, but you can probably see those sulfur yellow buds all the way down here. So this is a compound leaf. In fact, it's a bitternut hickory. Okay, so compound leaf there. Leaf, are our margins lobed or entire? This was an example. So we've got nice rounded lobes with deep sinuses. In fact, it's a white oak, so it's lobed. Is this statement true or false? This leaf is lobed, serrated, and compound. Do we see lobes? No, it seems entire. Do we see serrations? No, it looks nice and smooth. Is it compound? There's our bud. Here's our little leaf stem, and there's one blade. So it is false. All right, is this leaf entire or serrated? Well, we don't see any serrations on that. Looks nice and smooth. So we've got an entire leaf. Okay, which one doesn't fit this sequence? And I hit, sorry, but you all will get that. I hit down first. But if we look at A, we've got serrated leaf margins, B, serrated leaf margins, C, entire leaf margins, and then D, serrated leaf margins again. So C does not fit that sequence. And that is an example of a pawpaw leaf. And A and B are examples of our American beech. And B is, A and D are beech, and B is a hackberry. Okay, so the process of identifying trees, there's a logical sequence to identify the tree of your interest, and you use a tool that's called a dichotomous key. And you've probably used one of these before. You can use them for all kinds of organisms. We're just using them for tree leaves today. And this is a great dichotomous leaf key, and the tree finder, it's about $5 off Amazon. It is pocket sized. It's got about 70 pages in it, so it's not a big giant field guide to carry out in the field with you, which makes it very nice. It has many of our trees that we're going to find east of the Mississippi, and then a few that would have been added, like Scotch pine and stuff like that. And that's the tool that we'll work through here in just a few minutes. But this is a great little tool, especially if you're doing some programming with a group, because it is inexpensive. But let's walk through a super abbreviated example of a dichotomous key. So this is a really good, the way a dichotomous key works. It's di meaning two. So there's going to be two statements or two questions, and you're going to start at A or one or whatever. And you're going to read that statement or that question and see which one is most appropriate for your organism, your specimen that you have. So if we look at our example here, does the tree have needles or does the tree have leaves? Well, hopefully we are saying this tree has leaves. So we're going to go down to statements B now, or questions. Are the leaves opposite or are the leaves alternate? Remember, what type of leaf? Leaf arrangement now. And if we've got it circled here, we have, hopefully everybody sees alternately arranged leaves. So the next one's probably going to be about our leaf form. So it tells us to go down to C, and it asks if the leaves are simple or are the leaves compound. Well, this we see, can't really see the bud, but we see a stem and one blade. So we've got a simple leaf. So we're going to go down to F, and we actually get our answer now. that we have, what we have is here is a serviceberry with its scientific name, as Billy talked about in his section. So like I said, super abbreviated key. Right now, we're going to look at an actual example and using the tree finder. So on page 5 in that tree finder, it tells you where to start. It starts out with what type of leaf you have. Is it needle-like or is it broadleaf? And hopefully everybody says this is our sample here. It is a broadleaf. So we're going to go over to page 14. Remember what that symbol looks like, the lollipop tree or the stylized tree, and it's the top bracket. Now it's asking us about leaf arrangement. Do these leaves or buds grow opposite like this? See, this is what's great about this. It reminds you what all of these definitions are, or if the leaves or buds grow alternately like this. Well, I've made some circles for you on here, and you can see that these leaves grow alternately. So we're going to flip over to page 21, taking that little logo, that alternately arranged leaves logo, over to page 21. And now that's our middle bracket on page 21. And it asks if the leaves are compound. Remember, it's the leaf form. If it's compound, composed of several leaflets, you can tell leaves from leaflets because there are no buds at the base of a leaflet. Or if the leaves are simple and not composed of leaflets. Well, if we look closely, we can see that there's probably, that looks like a bud. We've got a leaf stem and we've got one blade. So we have a simple leaf. So now we're going to take our simple leaf over to page 28, and it's going to be the bottom bracket. Now it's asking us something about what that margin, the edge of that leaf, looks like. So it says if the leaf has neither teeth nor lobes, go to the next page, or if the leaf has teeth of any kind or wavy margin or lobes. Well, we have no lobes and no teeth. In fact, this was our example for an entire unlobed leaf. So we know we're going to the next page. And so we're looking for that symbol up on the next page, top bracket. Now it's asking us something about leaf tip. And we did mention it when we talked about our oaks with that little bristle tip. It's like a hair at the tip of that leaf. So it's asking if this leaf is tipped with a single bristle, like a needle, at the tip of a needle like you see here, or if it has no bristle at its tip. The leaf may be pointed or it may not, but it doesn't have a bristle tip. Well, this one doesn't have a bristle tip. And if you actually had this in your hand, you'd see it does not have a bristle tip. So we're going to go to the leaf without a bristle tip over on the next page. It's the top bracket. And it asks if the leaf is heart-shaped with veins branching from the base, or if the leaf is not heart-shaped. Well, let's look close at our leaf. Looks pretty closely heart-shaped. We got a nice point here. Maybe it could be a little more rounded up here, but it looks pretty rounded. Now let's look at our veins. It asks us if the veins are branching from the base. Well, it looks like they're all branching from the base of that leaf as they go out to the end of the leaf. So what we have just identified is a redbud, or an eastern redbud, as we also call it, or Cercis canadensis. So that's a really quick and easy way to learn to identify trees. Also wanted to point out, also shows you a picture there, so you can match it up with the picture that you see there as well. And then there's a picture of our eastern redbud. It's a beautiful tree, which will start flowering here shortly. It flowers before the leaves come out. And it is one of our trees that is in the Fabiaceae family, or the legume, the pea family, with those flattened pea-like pods with usually numerous flattened seeds in it. So a beautiful little spring tree. I did want to share a few quick tree ID resources with you all. If you don't have a handy tree guide or a tree dichotomous key, you can use the iNaturalist, which is a free downloadable app for your phone, where you simply take a picture of what the organism is, the leaf, and it's going to query its database and give you maybe 10 different examples that you're going to try to match up and choose from the one that looks most like yours. So that's an easy tool to use, especially when you're just out in the field and you want a quick ID. Virginia Tech Tree ID, they have a great website, lots and lots of fact sheets about trees. They also have a great online key, so you take your sample in to the house with you and you do your identify your sample based on their pictures. It is a very robust tree ID. It has hundreds and hundreds of species. So it can get a little dense, and they do have one for your phone, but because it does have so many species, until you're a little more comfortable using a dichotomous key, I'd probably stick with our tree finder. Arbor Day does also have a booklet tree finder that you can purchase. It's about $17 or $18, but it's nice. It's a dichotomous key as well. A little bit bigger than Pocket Guide though. And then we've got some other resources on our website, the UK Forestry and Natural Resources Tree ID videos, where Doug McLaren walks you through everything that we've kind of just gone over, what type of leaf arrangement, leaf form, leaf margins, and how you use that in a dichotomous key as little short videos. And then we've also got the UK Forestry Natural Resources Extension YouTube channel, and we have the Tree of the Week, and we've done 75 to 80 different trees. And this is more, you've identified the tree and you want to know more about it. So got little short videos about 6 to 8 minutes long on those videos that tells you all kinds of information about the trees, including some identification. So yeah, take a look, check those out as well. And then our horticulture department here at the University of Kentucky has Native Trees of Kentucky, where they've got 80 different trees listed there, and a fact sheet that goes along with each one of those. So check out some of those resources as you go out and start identifying trees this spring.